So welcome everyone. Welcome to Physics by RN. So we have our GATE examination on 3rd of Feb, and the exam happened well. And most of the students came to me and said that paper was basically moderate, but still they made a lot of silly mistakes. So paper was not hard. Paper was on the moderate side, and it was not expected from IISc to put such a basic level of paper. Although the paper is as basic, very easy questions, you have to have a good coverage of the syllabus to complete the paper. If you really had a very good coverage of the syllabus, you have covered the basic subjects, and then only you can actually recall the formulas that you were needing in the subject or in the paper. So I have more or less 20 questions students sent me, and I'm going to discuss those 20 questions and what are the possible answers for those questions and what could be the possible solutions. Okay. So a very first, and in the end, I am going to roughly give you an idea that what could be a cutoff for our GATE examination this year and what you can expect from this examination. Okay. So first question was from solid state physics, and the question was something like that a monoatomic cube, you have a monoatomic cube, it means every cube has it has a one kind of atoms only. Okay. And its atomic radius is given to you. So whatever atoms it has, the atomic radius was given as 1.56 angstrom. So when you have a throw the wavelength of 0.78 angstrom, so your X-ray shows a lowest order peak for 1110 plane. So what is a Bragg angle 2 theta? So basically you have to predict about 2 theta. So it is a question from XRD, X-ray diffraction, in which the radius of atom is given, which is basically 1.56 angstrom. The wavelength of the X-ray is given, the plane is given, and it is also said that it is lowest order plane, so first order plane. And also you need to ask about 2 theta. And also they were also asking the question that is it BCC or FCC, what kind of lattice it is. Okay. So we already know that let's say for our XRD diffraction, the formula that we use is equals to 2d sine theta equals to m lambda, where d is the separation between the planes, sine theta is a diffraction angle, m is the order, and lambda is the wavelength. Now, in order to get to our D, in order to find our distance between the planes, we basically need, what is this? Is it FCC or is it BCC? And how to identify that if it is FCC or BCC? Why it is FCC or why it is BCC? So in order to get the reflection from the planes, and if it is BCC planes, the condition is that H plus K plus L has to be equals to even. So if H plus K plus L is even, then you can get the reflection or the diffraction of X-rays from these planes in BCC. And for FCC, the condition is that HKLN, either all of them have to be odd or all of them have to be even. So in this case, the plane which is given to us is 1, 1, 1. So if you add 1 plus 1 plus 1, this will give you 3, which is not even. It means it cannot be BCC. But in 1, 1, 1, all of them, all of the H, K, and L are odd. It means you will have the FCC. Because in FCC, either all of 3 has to be odd or all of 3 has to be even. That is why you will have the FCC. So that is why I can assume, or I can say that this kind of lattice is basically FCC lattice. Okay. And in FCC lattice, we studied while studying the crystallography that in FCC, root 2a can be written as 4 times radius of an atom. What is A? A is the lattice constant. You know that lattice is a cube and every cube has some side A. So this is an A. So in FCC, root 2A can be written as 4R. So from there, your A comes out to be 4R by root. Okay. So you can calculate your value of 4R by root 2. So if you do that, you will get 4.41 angstrom. But in our formula, we need D. D is the distance between the planes. So the distance between the planes is given by lattice constant A divided by under root of H square plus K square plus L square. This is a formula also we studied in the crystallography. So now in the D, what you have to do is you have to first put the value of A, and then H plus S square plus K square plus L square will give you root 3. So finally, the value of D comes out to be 2.55 angstrom. Okay. So now we know about our D, we know about our order. What is the order? M is 1, right? So it is first order reflection, lowest order reflection. That is why I put m is 1. D you have already found. 2 you have already know what is 2. Lambda is lambda. So sine theta is lambda by 2d. So you put the value of lambda, you put the value of 2, you put the value of d. So sine theta comes out to be 0.15, or the theta comes out to be sine inverse of 0.15. So your theta comes out to be 8.63 degrees. Okay. And in the question, they are asking 2 theta. So if you do 2 theta, you are roughly getting 17.2 degrees and it should be FCC. So option were something like 17.4 degree FCC, 17.4 degree BCC, 8 degree something FCC. So you don't have to put answer 8 because they are asking 2 theta. They are not asking theta. Okay. So the answer to this question would have been 17.2 degree FCC. Okay. So if you have any doubt in this, you can either mention in comments, and so these are just the memory based questions. So I cannot guarantee that this was a question there. This is a question sent by the students, and I hope that this is a question is true, and this option was actually there in an exam. Okay. And if you have any other comments, or if you have any rectification in the question, you can mention in comments or in the chat box. Okay. Good. Then the second question was from the phase transition. Now this is not an actual question. This is a GATE previous year question, but the students say the similar kind of question was asked in the exam. Now they might have changed the value in an exam. So I am taking this question as such. So this is a GATE PYQ. So it was asked almost 20 years back in GATE, and the same kind of question they asked this year also. So what does this question say? This question is basically from phase transition. So the question says that the vapor pressure of the mercury, or no, vapor pressure in millimeter of mercury of the solid at temperature T is this. So for the solid state, the vapor pressure is given to you as ln P equals to 23 minus 3863 by T. And in the liquid phase, the vapor pressure is given as this. Then they are asking that what is the triple point temperature? What will be the temperature of triple point? So triple point is a point where all three lines meet, right? Sublimation line, vaporization line, melting line meet. So when they all meet, the pressure, temperature, and volume for all three are same. It means at the triple point, the vapor pressure of solid state and the vapor pressure of liquid state will be same. So basically you have to make these two states equal. ln P equals to 23 minus 3863 equals to ln P equals to 19 minus. So if I make all of these two pressures equal, and if I solve it little bit more, my temperature will come out to be 200 Kelvin. So this would be your answer if the numbers were same in the exam. If the numbers were different in an exam, then you basically have to change it a little bit based on the numbers which was given in the exam. But the concept was that you have to make the pressure of liquid state and solid state same. Okay. Then we have a third question which was on the superconductivity, and this question was very simple. It was on the Meissner effect. So Meissner effect basically tells you that if you have, so some diagrams were given and you have to choose the right diagram. So in superconductivity, what happens is that if you are at a temperature greater than critical temperature, then you are in a normal conducting stage. But if you are at a temperature less than critical temperature, then you are basically in the superconductive state, or you also call it as a Meissner state. So in the conductor state, what happens is that all the electric field lines can pass through the conductor. But in the superconducting state, no magnetic field lines can pass through the conductor. If once you reach the temperature lower than critical temperature, then all the magnetic field lines or all the magnetic flux which was there inside the material will go out. And inside now you will have no magnetic flux. Okay. So yeah, in the superconductor, they condition to that for T less than Tc, you will have this diagram which will be true. Okay. So for T less than Tc, you have to pick this diagram up. So I hope that you did this diagram well. So this was free marks, very easy question, but you have to study this. Okay. Then comes the magnetic properties. Okay. So now in the magnetic property of solid, they basically asked this graph where they were asking the susceptibility of the different materials as a function of temperature. And it was match the column kind of question. So they asked for the paramagnetism, ferromagnetism, diamagnetism, and I guess they also asked for antiferromagnetism. So this is directly a theory based question. I'm not going to go in the detail that why these graphs are like this. I have covered that in my notes very nicely. So what you have to see is that for paramagnetism, your susceptibility is inversely proportional to temperature. So your susceptibility will depend like this. For ferromagnetism, your susceptibility is dependent on C divided T minus Tc. So you have a state only after some temperature. Below that, your susceptibility is not following this. Because in that state, you are in not in pure ferromagnetism, you are in something else. So your inverse graph is only after temperature greater than Tc. And for antiferromagnetism, what happens is that your susceptibility first increases and then it decreases. Okay. So this was a graph for antiferro. And for diamagnetism, your susceptibility does not depend upon temperature. So susceptibility is constant and it is negative, and it is also constant. So it will not depend upon the temperature. So your susceptibility is basically this constant number, negative. So this kind of graph you must have seen in your options. So this was for the dia, this was for antiferro, this was for ferro, and this was for para. It is an easy question, but if you have not covered the topic, then it is difficult for you. Okay. So we cannot say that paper was very easy, because usually people, I also mentioned in one of my sessions also, that magnetism in the material they have started asking in last few years, and they kept doing it in this year also. But students usually miss out this topic. Okay. Then there was a question from semiconductor physics, which was basically the three lines graph was given. So somewhere it was ln ni by n naught on the y-axis was given, or ln sigma something was given. And on the x-axis, 1 by t was given, not t, it was given as 1 by t. So 1 by t was given. And in this graph, they were given the three intrinsic semiconductors. So there were three intrinsic semiconductor materials. Intrinsic means silicon, germanium, other can also be possible. So now there were three graphs, A, C, and B, and you have to tell that which of them have the more band energy. Okay, band gap. So for an intrinsic semiconductor, the equation for intrinsic charge carrier density means how many holes or how many electrons you have per centimeter cube is equals to Ni equals to N naught exponential of minus band gap divided by 2 kT. So basically your charge carrier density depends upon temperature. Okay. That is why you can clearly see that ln Ni by Ni is changing with temperature. So if I take this N naught on other side, so on this side exponential will be remaining, and then I take log on both sides. If I take log here, if I take log here, so then you will clearly see that ln Ni by N naught is directly proportional to 1 by T. Right? If I say 1 by T as one constant, so let's say 1 by T is Y. So ln N by Ni is directly proportional to 1 by T. So if you draw the graph of ln Ni by N naught versus 1 by T, you are going to get a straight line. And the slope of that straight line will be negative. And that slope will be equals to minus Eg by 2k. This formula we directly covered in the lecture of semiconductor physics. In the course, I covered this formula directly. Okay. And also we talked about the slope there. So slope is equals to minus Eg by 2k. It means if the band gap is more, slope is more. So in this graph, you can clearly see the slope of A is maximum, slope of C is minimum, medium, and slope of B is minimum. So that is why your energy gap will also follow the same rule. Your EA is maximum, your EC is middle, and EB is minimum. So based on that, you can clearly see more the slope, more the band gap. So that was a rule you had to see in the question. Okay. I hope that you have chosen the right order. Here the silly mistake can happen, that some people might think that this is more slope and this is less slope. That is one of the silly mistake that can happen. Okay. Another silly mistake is that they consider it ABC, they forgot to see ACB or something like that. If in reality the options were ACB, then you have this answer as exactly correct. Okay, good. Next question was on op-amp, and this was a summing amplifier. So they gave a summing amplifier, and they basically gave the three voltages: 2 volt, 3 volt, 5 volt, connected to the amplifier through the resistor of 2 kilo ohm, 3 kilo ohm, and 5 kilo ohm. And the feedback resistor is 4 kilo ohm, and you have to tell the voltage output. Now you also know that let's say the current I1 is coming in this branch, I2 is coming in this branch, and I3 is coming in this branch. Then all these three currents will go in the feedback. No currents goes in amplifier, because input current in the amplifier is always zero. So if this current is coming here, this will directly go in the feedback it will not go in the amplifier because input current in the amplifier is 0. Because amplifier has an infinite input resistance. Okay. So let's say the current in the feedback is I1, or let's say I. Okay, I. Then you can clearly say that this I is equals to I1 plus I2 plus I3. And that is exactly what I have done. That I is equals to I1 plus I2 plus I3. How do you find I? I is the voltage difference divided by resistance. According to the principle of virtual ground, if this point has a 0 voltage, why this has 0 voltage? Because it is grounded. So if this point has a 0 voltage, then this point will also have the 0 voltage. And the very basic reason is because there should be no current in input. So voltage difference in between these 2 points has to be 0. So what will be I1? What is a voltage difference? Voltage difference is 2 minus 0 divided by resistance, which is 2. So that is what I have written as 2 minus 0 divided by 2. In this, what is I2? I2 is what is the potential difference? 3 minus 0 by 3. So 3 minus 0 by 3. And in this case, 5 minus 0 by 5. So 5 minus 0 by 5. And in this case, you can clearly see 0 minus V out divided by 4. So 0 minus V out divided by 4. So if I solve this up, I will get minus V out by 4. 1 plus 3 plus 5, 1, 1, 1. So V out will come out to be minus 12. I hope that you haven't made the mistake of writing it as plus 12, because the answer should be minus 12. Until unless they have mentioned about any magnitude or something, which I don't think so they have mentioned it. So if you do that, your answer should be actually minus 12. Okay. So this was your simple question from electronics. Then comes the thermodynamic question. This was also a good question, and this was also actually checking your concept. Yeah, so it was NAT, so you have to write minus 12 as answer. In NAT, you can write minus. Okay, there is an option to write hyphen there. Good. So in thermodynamics, what was the question here? So you have an adiabatic isolated system. Your system is adiabatic, your system is isolated, and the volume change. So your system can change the volume, but your system has a constant pressure. So pressure of the system cannot change. Then which of the following 4 should be used to describe your system? Okay. So if you want to describe your system, you should describe it with some constant or some parameter which does not change. If you want to describe anything, the best way to describe it is to describe it with some parameter which is not changing, so that you can continuously define that with system very nicely. Okay. So let's see about enthalpy. If I talk about enthalpy, enthalpy is what? H equals to U plus V, PV. If I take the derivative on both sides for enthalpy, I will get dH equals to du plus pd. Now, from the first law of thermodynamics, you know that du is equals to dq minus pdv. So if I put the value of du as dq minus pdv, so pdv and pdv cancels each other out, and dH becomes equals to dq. And since it is an adiabatic process, the dq is 0. So it means dH is 0, which basically means the change in enthalpy is 0. If the change in enthalpy is 0, it means enthalpy is constant. So it means enthalpy is the best way to describe this system, because enthalpy of this system is not changing. Okay. So we will choose that our first option is best to describe this system. Okay, good. Next question was also very interesting, and it was from the vector algebra. I think it was MSQ question, in which there were 2 options. I do not exactly know the options because they do not came to me. So the question was that you have to do an integration, basically volume integration, of del square by 1 by r. So first of all, let's do del square 1 by r. And in order to solve this up, we will use a spherical polar coordinate system. How do we find del square? Okay, so del square is defined as del dot, you can say, gradient of divergence of gradient of 1 by r. So Laplace is equals to divergence of gradient. This is divergence of gradient. So first of all, we have to do the gradient of 1 by r. So if I do the gradient of 1 by r, which means differentiation basically, I will get minus 1 by r square into r cap. Then I have to do the divergence. So if I do the divergence of this thing, 1 by r square, curly by curly r, then I will write r square, and then I will write this thing and this thing is equals to minus 1 by r square. So you can clearly see that r square and r square cancels out and you get an answer 0. So in reality, your answer was 0. But this is true only if r is not equals to 0. If r is not equals to 0, then you can clearly see that r square and r square will cancel out. But let's say r is 0, then you cannot cancel 0 by 0, right? And in that case, I also taught in the foundation physics classes that if you have any such situation, 0 by 0 situation, then what you have to do is the value of this integration will actually become 4 pi into delta. And this is covered in the lecture. Okay. And this will only be true if r is equals to 0. If r is not equals to 0, then your answer is simply 0. But if r itself becomes 0, then you cannot cancel this r square and r square. In that case, your volume integration will become 4 pi into delta r. Okay. So whenever your differentiation is not allowed, in that case, you use delta. Okay. So in this question, you have to divide the question into two parts. One r not equal to 0 and one r equal to 0. Okay. So there were some options similar to that, in which one of them they were including the r0 and in which they were not including the r0. In both the cases, answer would have been different. Okay, good. Then comes the ninth question. Please.
They have mentioned the I is minus 4 pi.
No, it should be plus. It should be plus. In this case, it should be plus.
Given like minus 4 pi. That's why I got confused.
Yeah. There was plus 4 pi option, right? Also.
No, sir. I not remember seeing plus 4 pi. If I have seen that, shows on that option.
Differentiation give minus. Oh, sorry. Oh yeah. Here, yeah. Okay, sorry. Here minus is coming, right? So minus is coming. So yes, it will be minus. Sorry, it's good to remember recap. So it will be minus 4 pi. Yes, minus, because differentiation is giving this negative sign. So this negative will come here. I don't have the options, that is why. So this negative will come here. So your answer will be minus 4 pi delta if r is equal to 0. Okay. And this was the question. Now, next is, this question was already also repeated 2 times before. Once in JAM and once in somewhere net or something. This is also a solved example of DJ Griffiths, and I also mentioned it in the foundation physics classes. Okay. So looking at the option delta basically gives you a hint that, okay, we have to divide in 2 parts. Next question was very easy, that a stationary observer sees 2 flights and these 2 flights are moving away from each other. So one person is moving in this direction, one person moving in this direction, and this is your observer. So basically you have to tell that what is the velocity of P with respect to Q. Okay. So now this frame is S and this is your moving frame, because you have to tell the velocity of this now according to this frame. So now this frame is itself moving. So the velocity of frame itself is 0.5 c. Okay. And the velocity of this person according to this observer is minus 0.5 c. 0.5 c. So the velocity of frame is 0.5 c. Velocity of person is minus 0.5 c. Then to find the velocity of this person according to this frame, I have to use the velocity transformation formula, which is equals to v dash equals to v minus u divided by 1 minus uv by c square. Now v is minus 0.5 c, u is plus 0.5 c, so minus 0.5 minus 0.5 becomes minus c. Okay, and this thing becomes negative become positive, because v has a negative sign here, so negative will become positive. So you will get 1 plus 1 by 2 which is 1 by 4. Okay, so this you get is c by 1 plus 1 by 4, which is basically 4c by 5. So there was one option there which was mentioning 4c by 5, and in this case question the answer will be 4c by 5. Okay, any doubt if you have, please mention in the comments. Okay, fine. So this was another question. So far so now I would say the paper is 50-50. Some questions were straightforward, some question needed the good knowledge of formulas, but so far no question was having the heavy calculations. Whatever question came, if you know the formula, you can easily do it. Okay, image problem. Then there was a question on image problem, and this was also an interesting problem. So there are 2 charged particles having charge plus q and they are distance 2d apart. So one charge q is here and one charge q is here, and the distance between them is 2d. Okay. Now a spherical grounded conducting sphere. So you could put a spherical grounded sphere in the middle of these two charges. So you place this sphere in the middle of two charges, and this sphere is grounded. Okay. And the radius of this sphere is a. So a is the radius of this sphere, and it is mentioned that the a is much less than d. So this diameter is much less than this diameter. Okay. So this thing we have to keep in mind. So then we have to find various things, and this is basically MSQ question. So first option was that total charge induced is equals to minus 2qd by a. Okay. And potential is zero at the surface, and potential is not zero inside. So first, let's talk about these three options. Since the surface is grounded, the potential is zero on the surface. That is for sure. Because whenever you ground, the surface becomes at the zero potential. So potential is zero on the surface. And for the conductor, potential inside the conductor is same as the potential on the sphere. So let's say whatever is the potential on the surface of the conductor, the same potential will be there inside. Because inside we do not have any electric field. So in order to come from the surface to inside, you don't have to do any extra work. So if there is no extra work, there is no change in potential. So whatever is the potential on the surface, the same potential will be there inside the sphere if the sphere is conductor, because electric field is zero inside the conductor. Okay. So it means if the potential is zero on the surface, then the potential is also zero on the center. So potential is zero on the center. But the second option says that potential is not zero inside. So that is wrong. Second option is true, but the third option is wrong. Now we come to what is the charge induced. The total potential at the center is because of the three people. One is because of this charge, one is because of this charge, and one is because of the induced charge, because some charges will be induced in this body. So because of all those induced charges, there will be some potential at the center. Okay. So potential at the center is basically because of three people, VQ, one here, and one is V induced. And total potential combined together to give you zero. So what is the potential because of this charge here? So potential is always defined as KQ by distance. So the distance between these two is d. So potential because of this charge at the center will be KQ by d. So potential is KQ by d. Potential because of this charge at center will also be KQ by d. So that is also KQ by d. Now whatever is the charge induced on the surface, the potential because of that and the center will be KQ by r. Whatever is the radius is a. Because if the charge is here, then the potential because of that at the center will be equals to KQ by this distance, and this distance is a. So potential because of the induced charges is equals to KQ by a. Okay. So if I do that, if I keep this thing here and if I bring all two on the other side, so Q induced by A is equals to minus 2Q by D. So which basically means that Q induced is equals to minus 2QA by D. So it seems that our first option is correct, but according to the option sent to me, it is minus 2Q D by A. But our answer is minus 2Q A by D. So if this is the option, then it is wrong. But if this is the option, then it is correct. So you have to keep that in mind, that if the option was this one or this one. So if the option was D by A, then it's wrong. And if it is A by D, then it is correct. Okay. So this is the option. Okay. So our answer comes out to be minus 2QA by D. So we solved first three problems. Now let's talk about the fourth option. So fourth option says that for A, so now they are giving some particular value of A. For A greater than D by A, forces on both charges are towards each other. So whatever the net force is acting on this charge, it is acting towards this side, which means towards the other charge. And we have to say that if it is correct. So let's see what are the total forces. So first of all, let's simplify this. First, assume that there is a charge Q here, then there is a charge Q here, and instead of this entire sphere, we can assume that there is a point charge here whose value is equal to Q induced, and Q induced we calculated as minus 2QA by D. So remove the sphere and assume that there is a point charge having this charge sitting here. So now on this charge, what are the two forces acting? One is the repulsion between this charge and this charge. So that repulsion will be on this side. Okay. One is an attraction between these two charges. So that will be in this side. So let's calculate that magnitude. What will be F1? F1 is the force of repulsion between Q and Q. So that will be equals to KQ square by the distance. Distance between them is 2D whole square. So this is a force which is acting towards the left side. Now the force of attraction which is acting in this side is between this charge and this charge. So that will be equals to K Q1 into Q2, which is 2QA by D, divided by distance between them square, which is D square. Okay. So if you do this, it will come out to be KQ 2KQ square A by D cube. If you want this force to be towards charge Q, it means F2 has to be greater than F1. So if I make F2 greater than F1, then your net force will be towards the other charge, right hand side. Okay. So F2 is greater than F1, which means that 2, because KQ square by D square is same in both. So 2A by D cube, 2A by D cube should be greater than 1 by 4D square. Because if you square this up, you get 4D square. And if you look at from here, you get 2A by D. So which basically means that 2A by D is greater than 1 by 4, or A is greater than D by 8. It means if your distance is greater than D by 8, then yes, the overall force is towards the other charge. And that was the concept. So your option number D is also correct. Option number B is also correct. A will be correct if the option which is given to me is exactly that, or if not, if it is reverse of it, then A is wrong. Okay. So in A, your Q and U should exactly match this. If it is matching this, then A is correct. Otherwise, A is wrong. Okay. So your B, D are confirmed right. C is confirmed wrong. A can be true or wrong. Okay. Good. So these were the first 10 questions. Then comes the beta negative decay. So this was a direct graph from the notes which was provided to you. Also, I covered it in the lecture. That what is the energy spectrum of beta negative decay? So for whenever the beta negative particle comes out, electron comes out, so nucleus is pulling it towards itself. Because of the Coulomb force, whenever the electron comes out of the nucleus, electron is experiencing the force in the backward direction because of the nucleus. So basically it is trying to slow down. So the beta negative decay graph is basically shifted towards the low energy side. You can clearly see this peak is towards the lower energy side. However, for the beta positive decay particles, whenever the nucleus positron comes out of the nucleus push that positron. So kinetic energy increases, which basically means that for the beta positive particle, the spectrum is shifted towards a higher energy. That is why you see that the maximum is towards a higher energy. So in the graph, they were asking you about the beta negative decay. So this was the graph you have to take it down. So it is a graph between counts versus energy. So this is known as the energy spectrum of beta negative decay. We covered it a lot in the theory. Okay. Then comes the 12th question. This was from the perturbation theory, from the quantum mechanics perturbation theory. Okay. And the question was very simple. Actually, if you have solved the previous year questions or solved examples of the notes I provided you, then you could have easily solved this problem. And the problem was something like this, that what is the first order correction to the ground state of the one-dimensional infinite well for the perturbation as shown. So there was some perturbation shown to you. So outside obviously potential is infinity, inside potential is 0. And there is a small perturbation of V naught from the distance 3a by 4 to a. This is 0, this is 3a by 4, and this is a. Okay. So your perturbation is existing from 3a by 4 to a. So then you have to find the first order correction. So if you do the first order correction, what will happen? If you do the first order correction to which ground state? So ground state wave function is given by under root of 2 by a. It is asked in the fourth energy state. Okay. Okay. So if it is asked in the fourth energy state, so a student sent me the question in ground state. So if it is fourth energy state, then it will be 4 pi x. Then I have to write 4 pi x here as well. Okay. Okay. So then the first order correction will be, the formula for first order correction is phi 1 v naught phi 1 inner product. So this thing is defined as, okay, so now I don't have to write phi 1, I have to write phi 4 because it's a fourth order. So phi 4 here, phi 4 here, phi 4 here, not a problem. Then 2 by a, 2 by a remain constant. So from 1, 2 by a came from here, 1 come from here. So under root and under root becomes square. So it is 2 by a. Then the perturbation is v naught, so v naught. Then comes sine square 4 pi x by a. Okay. Now you can take v naught common, and you know this property that sine square theta equals to 1 minus cos 2 theta by 2. So basically that is I'm using here. So now it will become 1 minus cos 8 pi x by a. Okay. So here I get also, if I integrate this, integration of, so this 2 I can bring out and I can cancel this 2. So if I do that, in outside I am left with this v naught by a. So integration of 1 is x, and integration of cos 8 pi x is sine 8 pi x by a divided by 8 pi. And then your limit has to go from 3a by 4 to a. Okay. So if I put my limits in x, I will get a minus 3a by 4. And this thing will become 1 by 8 pi by a. And if I put a here, I will get sine 8 pi. Sine 8 pi is 0. But if I put 3a by 4, then I get, what do I get? 8 pi by a into 3a by 4. So then I will get 2. So 2 into 3, that, and then I will get 6 pi. Okay. So this is also 0. Sine 6 pi is also 0. So this thing will also become 0. So finally you are getting is v naught by a into a by 4. So finally you are getting an answer of v naught by 4. This was your correction in, this should be your correction in the fourth state. Was this the answer you are all getting? You were getting v naught by 4. Okay. So this was the answer you should be getting. Okay. So v naught value was also given, which was h cut square or h square by 4ma square. Okay. So if you put that value, you will basically get h square by 16ma square. Okay. So then you put these values also. So something more you have to do. So exact question I don't have. So if v naught is given, then you have to put the value of v naught, and then you can find the final answer. Okay. Good. So very straightforward question from perturbation theory. Okay. Then comes the question from digital electronics. So a Boolean expression was given to you, and that Boolean expression was b into a plus b plus a into a plus b bar. And they are asking that how many number of basic logic gates are required, not NAND gates or not no. They are not asking universal logic gates. They are asking that how many basic gates are required. That just the basic gates. So if you do that, what are the basic gates are and, or, and not. These are the three basic gates. Okay. So if you do the first thing, then you get, if you multiply this, you get ba plus b square. If you do this, then you get a square into ab dash. Okay, good. Okay, so then if you do ba, b square can be written as b, a square can be written as a, and ab dash remain as such. Then from the first two, you have to take b common. So if you take b common, you get a plus 1. And from these two, if you take a common, you get 1 plus b. If you add anything to 1, that thing becomes 1. So a plus 1 is just 1. So b into 1 is b. 1 plus b dash is just 1. So 1 into a is a. So basically, finally, you are getting is a plus b. So if you're finally getting a plus b, it means you only need one OR gate to implement this. So the answer to this question should be 1, because you only need one OR gate to implement this Boolean expression. So this question was just to simplify your Boolean expression and then to find how many OR gates you need. Okay. So that was pretty straightforward question. Then comes the canonical transformation directly coming from the notes. Nothing else you have to do it. So they were given you F1, and I also gave you the tricks to remember this. That if they ask F1, which is basically the function of small q and capital Q, and it is equals to small q into capital Q, Then the formula for small p is equals to curly f by curly q. Curly f by curly q, if I do, then I will simply this thing will be considered as constant, so I will get capital Q. And then the formula for capital Q, P comes out to be minus curly f1 by capital Q, curly Q. So if I do curly by curly Q, so this thing will be considered constant and its differentiation will be 1. So then you get minus Q. Then they were asking the ratio of small p by capital P. So if you do the ratio of small p by capital P, you will basically get minus capital Q by small q. So this was your answer to this question. Okay. So this was your question number 14. Again, simple, straightforward question. But now you see the question was simple. But what if the student forgets the formula in exam? They do not remember that what is the formula for canonical transformation. This can happen. So the same question becomes difficult for that student. So in that perspective, the paper was not, you can call it as easy. You have to keep it at moderate because you have to have remember the formulas that are required. Okay. Then there was another digital electronics question. So it's a good thing that they have now stopped asking the questions from flip-flops or from the other horrible topics of digital electronics. They are basically sticking themselves to the gates. And maximum question they are asking is from the gates. This year, all the digital electronics questions are from the gates. Okay. So now they have given you two signals. One is P and one is Q. I am not very sure that exactly these were the two signals, but as the student gave me the question, I think these were the two signals which they have sent. And this is your circuit. So what do you have to do? So first of all, let's understand what circuit is this. So you can clearly see this is basically NOT gate. This is basically NAND. But if you combine both the inputs of NAND, it becomes NOT. That is exactly what is happening. So this is also NOT and this is also NOT. So both are acting as NOT. So this will be P bar and this will be Q bar. And in the final step, it is NAND. In NAND gate, what happens? You first multiply both. So P bar into Q bar, and then you do the modulus of that. And then you can use De Morgan's theorem to say that it is P bar bar plus Q bar bar. So which is basically P plus Q. So this graph is basically doing the task of adding both P plus Q. So you just have to add both. So initially both are 0, 0. So you get 0. Then you have 1, 0. So you get 1. Then you again have 0, 0. So you get 0. Then you have 1, 0. So you get 1. Okay. Then you have 0, 0. So you get 0. Okay. Then you have 0, 1. So you get 1. And then you have 0, 0. So you get 0. Okay. So this kind of output you must have expected. Okay. So this was your, this should be expected in the answer. And I think this was your final answer. Okay. So another very simple question from digital electronics. Then another simple question from Lagrangian and Hamiltonian was asked. And that question was also very straightforward, that they were giving you some Lagrangian, mx naught, m omega square xy. Okay. And then they were asking you about x naught, y naught, px naught, py naught. Very simple idea you all have, that in order to find x naught and px naught, you need Hamiltonian, because then it's a Hamiltonian's equation. Hamilton's equation basically gives you the value of x naught and gives you the value of px. But Lagrangian is given to me. First, I have to convert it into Hamiltonian. In order to convert to Hamiltonian, you have to write x naught and replace it with px. You have to replace y naught with the py. So basically, I need to know what is px, py. What is the relation between them? So px is given by curly L by curly x naught. So if I do curly L by curly x naught, I will get my naught. From there, my y naught comes out to px by m. Similarly, if I have to find py, then it is equals to curly L by curly y naught, which is basically mx naught. And x naught will come out to be py by m. Okay. Then the Hamiltonian is very simple. Summation of q naught p naught minus L. So summation of q naught p naught, which means x naught into px plus y naught into py minus L. And L also you have to write in terms of px, py. You cannot write your L in terms of xy. Sorry, x naught, y. Okay. Because Hamiltonian is a function of x and px, y and py. There is no x naught in the Hamiltonian. Okay. So if I do that thing, so basically x naught px naught, so which will be basically equals to, if I put the value of x naught, that is equals to py by m. So here I will get Px Py by m, and here I also get Px Py by m. In the Lagrangian also, if I put the value of x naught and y naught, and I will get something like this. So if I solve this up, my final Hamiltonian will come out to be this. And you can check this calculation. You have to be very precise with that. And this is a very simple calculation, and your final Hamiltonian will come out to be this. Now it's a simple game for me. Now it's a straightforward rod. I just have to play. So x naught is equals to curly h by curly px. So if I do my x naught as curly h by curly px, you get py by m. And my y naught is curly h by curly py. If I do that, I will get px by m. Then I have to find px naught. So px naught is minus curly h by curly x. This is also the formula. So if I do that, I will get minus m omega square y. And then py naught. Py naught is equals to minus curly h by curly y. That is equals to, if I do the partial derivative of this y, this will be 0. And this will get minus m omega square x. So these were the 4 options that you have to choose from your given options. If you have chosen the right options, then it is good. Otherwise, I don't think any mistake should happen in this, because I feel that these kind of questions happened a lot in GATE. If you have solved the PYQs also, then you might be aware about these questions. So these questions can be categorized as easy ones, okay? Because any GATE aspirant is expected to know this at least, okay? Then this was a question, again, this was, I would say, from electronics, this was little difficult problem, because this actually involved some basic knowledge of circuits, which I'm going to cover as a first topic in my gist, that how to basically understand the basic logics, or how to understand the basic voltage division, current division, all of that. Okay. So input voltage was given to you. So input voltage was something like this, minus 3 volt to plus 3 volt. And it is a square wave. And the circuit is given to you. In the circuit, you have a capacitor, and in the circuit, you have a diode. And you have to find this V output voltage. So first of all, let's bring the negative cycle, because you have a negative. So first of all, your voltage will be minus 3 volt. So you are giving the input as minus 3 volt. So assume that you are giving minus 3 volt here and 0 volt here. Okay. And when you are giving the negative voltage, what will happen? What will happen? Your diode will get actually forward biased, because you are applying this negative voltage. This will get forward biased. If this get forward biased, then you have a clear cut capacitor only. So basically, you are charging your capacitor. So you are charging your capacitor with the voltage of minus 3 volt. So what will happen? Your capacitor will also have now this much voltage, which is equals to 3 volt. Because your diode becomes like a wire. Whenever it's forward biased, diode becomes like a wire. So once the diode becomes like a wire, and this is like a battery, because the constant 3 voltage is given. So now what you are basically doing is that you are charging your capacitor with the battery of minus 3 volt or 3 volt. So your capacitor is being charged by the battery. So it means your capacitor will also get the potential of 3 volt. So now your capacitor is ready, and the potential on your capacitor is 3 volt. And this side is negative and this side is positive. Okay. So this side is negative and this side is positive. So now bring the positive cycle. So now your voltage suddenly becomes from minus 3 volt to plus 3 volt. So if you give your voltage from minus 3 to plus 3, it means this is plus 3 volt and this is 0 volt. So basically this is acting like a battery. This is plus and this is minus. So this I have seen the battery of 3 volt. And your capacitor is charged. So this is also like acting like a battery of 3 volt. So now you have two batteries, one this 3 volt and one this 3 volt. Initially you had an uncharged capacitor. In the first negative cycle, you charged that capacitor. So you charged it and you gave it a voltage of 3 volt. Now your capacitor is also like a battery. So now you have two batteries, one external 3 volt and one this 3 volt. But now your diode is reverse biased. So if the diode is reverse biased, you have to open that circuit. So now you have opened that circuit. So this side will be positive, this side will be negative. So you have to tell me about the V out. Okay. So this circuit can be written equivalently like this, that this is a battery, and this is open circuit. So if I apply the Kirchhoff voltage law, so you can apply the Kirchhoff voltage law. First, I see the negative terminal. Whenever I see the negative terminal, I get plus 3. Then again, I see the negative terminal, again I get plus 3. Then I see the positive voltage, so I have to write minus V output. And then since the loop is closed, I have to write it equals to 0. So from there, V output comes out to be 6 volt. it means your voltage is varying between V output 0 to V output 6. Why V output was 0 initially? Because you are replacing it with the wire. So if you are replacing it with the wire, then this point and this point has the same potential. Every point of the wire has the same potential. It basically means that the potential difference between the two ends of the wire has 0 voltage difference. So initially the voltage difference was 0. Now the voltage difference is 6 volt. So basically your voltage is what you can say, oscillating between 0 and 6. So this will be your final graph where your voltage is oscillating between 0 and 6. I'm very sure that very many few students will be able to solve this problem because to be very frank, this kind of question requires a decent knowledge of circuits, and more or less we lack that kind of practice in our graduation and post graduation. Okay, fine. So this was an interesting question from electronics. Then comes the Zeeman effect. Very straightforward question from Zeeman effect was there. They are basically saying that how many number of Zeeman lines will be observed between the n equals to 2, L equals to 1 and n equals to 1, L equals to 0. And some weak magnetic field is given to you. So obviously Zeeman effect happens in weak magnetic field. Okay, so you have two things, n equals to 2, L equals to 1. So Zeeman effect happens in steps. So initially you have two states. First LS coupling happens and gives you J, and then that J splits. Okay, so that is how your Zeeman effect happens. So you have L equals to 1, and obviously the spin of electron is half. So S is assumed to be half. You can assume it. Okay, and that's a good assumption, and that's a true assumption because electron spin is half. So L is 1 and S is half. So now there will be LS coupling. L and S will combine together and give you J. So the value of J goes from L minus S to L plus S. So L minus S is half and L plus half S half is half, 3 by 2. So your J can have two values, half and 3 by 2. That has exactly what I've showed here. So L equals to 1, combining with the S, giving you the LS coupling and giving you two states. One is J 3 by 2 and one is J 1 by 2. Okay. Similarly, in the bottom level, L is 0 and S is half. So half minus 0 is also half. Half plus 0 is also half. So your level does not split. So L equals to 0 remains one level only, and that level has a J value of half. So this happens when you have a LS coupling. But now what happens, because of the magnetic field, this further splits. So J splits into two J plus 1 levels, right? And having different values of Mj. So you know that if J is 2, then Mj can be -2, -1, 0, 1, 2. So basically from minus J to plus J. Okay. So that is exactly what will happen. So your J 3 by 2 will split from -3 by 2 to +3 by 2. So it will be -3 by 2 plus 1 by 2, sorry, -1 by 2, then +1 by 2, and then +3 by 2. So your J 3 by 2 splits into 4 level, -3 by 2, -1 by 2, 1 by 2, and 3 by 2. Similarly, your J 1 by 2 level splits into -1 by 2, +1 by 2. How do I know that how many levels it is splitting into? It has to split into two J plus 1 levels. So if the J is 3 by 2, then it is 2 into 3 by 2 plus 1, which is basically 4 levels. And that is exactly what is happening, 4 levels. And if J is half, then it has to split with 2 into half plus half, 2 levels. And that is exactly what is happening. So your J 3 by 2 level splits into 4 levels. Your J 1 by 2 level splits into 2 levels. And your J 1 by 2 level again splits into 2 levels. So now the spectral line has to come from here to here. Basically, from these levels to these levels, your lines have to come. Your transitions has to happen. And for that transitions, you have a selection rule. In a Zeeman, you have a selection rule. And that selection rule is that your delta mj, means the change in value of mj, should be 0 or plus minus 1. By the way, these are the values of mj. Okay, so these are your mj values, 3 by 2, 1 by 2. So the change in mj should either be 0 or it should be plus minus 1. If this rule is obeyed, then that transition is possible. Otherwise, that transition is not possible. So I have shown this diagram again. So basically, you can see 4 plus 2, 6 levels here and 2 levels here. So I am showing these levels again. And now I'm showing the transitions. Okay. So first of all, let's start with this. So let's see how can it go to this level. So can this line go from here to here? So mj is going from plus half to plus half. So yes, half minus half is 0. So there is no change in mj. So this line is possible. Then can this line go to here? So it is going from plus half to minus half, which basically means minus 1. So this is also possible. Then let's talk about this. Can it go from minus half to plus half? Yes, minus half to plus half means delta mj is 1. That is possible. Then it is going from minus half to minus half. So delta mj is 0. So this is also possible. Then the same thing you have to look for minus 3 by 2. So what are the possible values? So can minus 3 by 2 come here? Yes. Can minus 3 by 2 come to here? No. Because if minus 3 by 2 go to plus 1 by 2, it is mj is 2, which is not possible. Okay. So in total, you will see that 6 these and 4 these possibilities are there. You can look at all the transitions and you have to basically make sure one thing, that delta mj is either 0 or plus max. By doing that, you will actually see that 4 plus 6, total 10 transitions are basically possible. Okay. So total 10 transitions are possible, and that will be your answer, that in how many number of levels your Zeeman line will split. So your answer is it will split into 10 lines. So 10 was the answer for this question. Okay. So that was a question from Zeeman effect. There was not many questions from atomic and molecular physics. Basic question was already. Then comes the electrostatic question, which was a decent question, and electric field is given to you, which is basically x I cap plus y j cap divided by x square plus y square, and you have to find the flux through the sphere. Flux is basically equals to E dot dA closed integration. Now you can clearly see that this electric field is present only in xy plane. So only in this xy plane your electric field is present. You can clearly see that. Your electric field does not have any j cap. So your electric field is only present in xy plane, this plane. Okay. And it means this is your electric field, like this. So electric field is coming like this. Okay. It's only in one of the plane. So there are many planes in the sphere, but it is only in one of the plane. It is only in your xy plane, which is basically means z equals to 0 plane. Okay. Now I can replace this electric field as, this thing can be written as r vector. In xy plane, if I'm only in xy plane, then my r vector can be written as x I cap plus y j cap, and my r square can be written as x square plus y square. So this thing is r vector and this thing is r square. So I get electric field as r vector by r square, and r vector can be written as r into r cap. So one r and one r cap cancel. So your electric field comes out to be r cap by r. What about dA? If I talk about the small area element of this, so your area element for this, for the disk, how will you do that? So this is just a, I'm not very sure about this solution. I'm giving this solution, but since I am not very sure about this solution, so dA vector can be written as dA into r. This is my idea. So dA vector can be written as dA into r cap, and then if you do the dot product of E dot dA, so E is 1 by r. This, if I do the dot product of this and this, I will get 1 by r into dA, and dA can be written as r dr d theta. We also know that value of dA can be written as r dr d theta, and in the denominator also you have r, so you have this r as well. So now this r and this r will cancel out, and you have to do an integration of dr from 0 to capital R, and then you have to do an integration of d theta from 0 to 2 pi. So integration of dr will be r, and d theta is 2 d theta. You will get 2 pi r. So I think the flux should be 2 pi r. Right? I think the flux should be 2 pi r. If main idea comes from the option that how it was given in the paper, I think it was given something like 2 pi kr, and the value of k was asked something like this, and k should be 1 in this case.
This was a numerical answer type, so no option where the
They
have given the
they
form
were given like this, na, 2 pi nr, and give the value of n, right?
Yes, sir, exactly. So now 2 pi, 2 was not given, but pi n pi kr have been given.
Pi n kr. So 1 k was
Yes.
also.
Yeah, K was actually given in the electric field term also, so that would multiply.
Oh, so K is given, so
Electric.
we can ignore that. So basically the value of N will come out to be 2, right?
Yes, sir.
According
Okay.
to this solution. 2 was the answer. So this is my approach. I am not sure about this, but the first thing that came to my head is this. So I think answer to this will be 2, but I have no shame in accepting that I might be wrong, because I am also a person, but I think more or less according to my electromagnetism idea, this answer should be 2. Yeah.
Sir, can we use divergence theorem?
Yeah, that is exactly what I've done. So this is the integral version of divergence theorem, right? So in divergence theorem, it will come to the charge rho by epsilon naught. What you will do with that? You understand my idea? Divergence theorem basically brings E dot dr. You are saying, writing it as del
Sir,
dot
I'm saying that
E. Yes.
if we
Yes.
take divergence of E,
Huh?
then it was coming 0. And we know that for the closed surface, any function dot dA is equals to divergence of that function dot d tau. मतलब vector calculus से.
Yeah. So if you do del dot, it is coming out to be 0.
Yes, sir. It was coming. Let me check again calculation, but in the exam it was coming 0.
No, it will not come 0, because if you carefully see, del dot E is equals to 1 by r square del curly by curly r into r, and this thing we already studied is r cap by r. So this thing will be, yeah, oh yeah, it is coming out to be 0. It is coming out to be 0. But in that case, you know what is the problem? Why it will fail? Because there r is equals to x square plus y square plus z square. You see the difference?
Yes, sir.
You have to, in that, what you are assuming, if you are actually, that's the thing, na? If you're using spherical polar coordinates and you are finding the divergence, right? So then you are basically assuming that then your r is equals to x square plus y square plus z square. But if you do the divergence, not by converting it into x, y, z, just do the divergence of this thing by using the Cartesian coordinates. Don't use the spherical coordinate. Then your answer of divergence will not come out to 0. Okay. You understand my point? In spherical polar coordinates, you are assuming that there is also z square, because spherical polar coordinates automatically assumes that. Fine.
Sir, here the using Cartesian coordinate also, the divergence was coming to be 0.
Coming out to
Yes,
be
sir.
0.
Yeah.
Yes, sir.
Yes, sir. But sir, that should not be the case here, because flux can't be 0 here. The same thing is related with delta function also, right, sir? Dirac delta function.
If the, let's say del dot E comes out to be 0, then
Same
if the
thing.
del dot E is coming out to be 0, then why not flux is not? Flux has to be then 0. Why not? Then how will you prove your divergence theorem wrong?
Yes, sir. That's what the Griffith book has compensated for delta function, Dirac delta function, because E dot ds is not coming to be 0, but divergence is coming to be 0. That concept, I think, is being used here, sir. The same thing
Deep
you
concept.
did here, and you did here the same thing I also did, but I did a mistake by taking the surface area of the whole sphere.
Okay. So little deeper concept. Okay. So good direction to look into that. Even though the divergence is coming out to be 0, I stopped to find divergence because I thought there is no z. So I didn't went on finding the divergence. So yeah, 2 is correct. But the concept which we are getting to learn in this, that even though the divergence is coming out to be 0, flux is not 0. That is very brilliant concept. I think that concept
Okay.
should be looked upon. I will look into that also. Good. So answer I think should be 2. And then the 20th question which I have is that you have the two matrices. It was a very simple question. Two real matrices A and B. Do they have the same eigenvalues? So one of them is an upper triangular matrix and one of them is a diagonal matrix. In both the cases, the eigenvalues are just the diagonal elements. So its eigenvalues will be 1, 1. So its eigenvalues will also be 1. Okay, so diagonal elements are the eigenvalues if you have an upper triangular matrix or a diagonal. So its eigenvalues are 1, 1 and its eigenvalues are 1, 1. So basically both of them have the same eigenvalues. Then are they diagonalizable? The only condition for diagonalizability is that they should be unitary. Unitary means A into A dagger should be identity. But if you do A into A dagger, it does not comes out to be identity. It means A matrix is not diagonalizable, but B matrix is diagonal. Okay, so your B comes out to be wrong. Then comes that are they commuting with each other? So is AB equals to BA? Yes, B matrix is an identity matrix. You put it initially or you put it afterwards. It will give you same answer. So AB and BA will be same. So yes, they are commuting each other. And then fourth, are they having the same eigenvalues? So yes, quantum mechanics says that if two matrices or the two operators are basically commuting with each other, then they share the same set of eigenvalues. Then their eigenvectors are same because you can measure them simultaneously. So since they are both commuting with each other, then they have to share the same set of eigenvalues. So your option D is also. So your A, C, D will be correct and B will be wrong in this case. Okay. So that was the 20 questions I wanted to discuss for GATE, which happened yesterday. Okay. So now our next plan is
Sir.
that first we understand the cutoff of this. Cutoff is not going to go very high. Don't worry about that. I'm just going to give two numbers. One is that cutoff will be 30 to 32 marks. Okay, so somewhere in between. It can be less than that, but it will not cross 32. And if you want an interview call from a good IIT, and if you're crossing 50 marks, somewhere between 50 to 52 marks, if you are getting, then you will get an interview call for PhD from good IITs. Okay, except IIT Madras or something, except that you will get an interview call at this much marks. So based on the paper I'm looking at, these two are the good options. If you are getting somewhere in between, you can expect, with this you can expect under 250 rank, and with this expectation you can expect that qualification will happen. If you are in somewhere between 40 to 46 marks, then you are in a very bad, you can say, patch. Always in a competitive exam, there is a patch in which in those 5-6 marks, there are huge amount of students. So it is possible that that patch will somewhere be between 40 to 46 marks. So if you're crossing 46, reaching up to 50, 52, then I would say that your chances are very good for interview call from good IITs. Okay. But anyway, the next exam is JEST exam. I have shared the entire strategy of JEST. You can go and watch the video on the YouTube in which I have covered entire strategy of JEST, and I have launched 1 month of course for JEST also, which is the most effective course for JEST. And if you cover that course up, your JEST preparation will happen very nicely and smoothly. Okay. So with this, I wish you all best of luck for your next exam. And I hope that this GATE exam gave you the very good learnings that you will remember for your next examinations. So bye bye everyone. You are free to
Sir, can I add one
contact
more
me.
question?